I was just looking at a strand of fiber optic cable this morning, and it got me thinking about the speed of light. We usually see that as, a constraint, the ultimate speed limit.
The cosmic speed limit, yeah.
But I came across a proposal that just completely flips that physics on its head. What if you make the journey long enough so the delay, the latency, becomes the hard drive?
It sounds totally backwards, doesn't it? But you're talking about the latest idea from John Carmack.
The very same, the programmer behind Doom.
He's suggesting we replace static RAM chips, at least for some AI tasks, with get this, a 200-kilometer loop of fiber optic cable.
200 kilometers? Okay, let's be real for a second. That seems like a logistical nightmare. You're not exactly fitting a 200-kilometer spool of glass inside a server rack.
Well, it's big, sure. If you coil it tightly, it's maybe the size of a refined hula hoop. But the physics are completely sound.
So it's not just a thought experiment?
Not at all. Carmack ran the numbers.
Yeah.
If you're blasting data at 256 terabits per second into that loop.
That's an incredible speed.
It is. And the time it takes, the light to travel from the start to the finish, lets you hold about 32 gigabytes of data, just in flight.
So the storage is the journey. The data is stored just because it hasn't arrived yet.
Precisely. He calls it a recycling fiber loop. And, to understand why anyone would even build this, you have to look at the memory wall.
Right. The energy problem.
A huge energy problem. Right now, moving data from memory to the processor takes about 100 times more energy than actually doing the math on it. That's the real bottleneck in AI.
And with these huge language models, you're fetching the same model weights over and over again.
Exactly. But neural networks are deterministic. We know exactly which weight we're going to need and when.
So instead of fetching, you just time it.
You just stream the weights through this loop of light. They hit the processor at the exact moment the math needs them. It turns storage from a static thing into a perfectly synchronized flow.
Which is. It's just fascinating because architecturally, this feels familiar. This is basically a photonic version of delay line memory from the 40s, right?
It is. You're spot on. Before we had silicon, the first mainframes used these long tubes of mercury. They'd send sound waves through the liquid.
And the travel time of the sound was the memory.
That was the memory.
I think I read somewhere that Alan Turing wasn't a big fan of the mercury. He actually proposed using gin.
He did.
Yeah.
I think modern engineers probably prefer lasers to liquor, but it just proves the point. A good idea never really dies. It just waits for better technology.
It's a brilliant way to rethink hardware. And speaking of brilliant ways to apply new tech, that's a perfect segue to our sponsor, Embersilk.
A very smooth transition.
While Carmack is figuring out how to store an AI in a beam of light, most of us are just trying to figure out how to use AI in our actual, daily business workflows.
And that's the real challenge. It's about practical application. Embersilk specializes in that, whether it's training, automation, or custom software development. They help uncover where AI can really make a difference.
Exactly. So if you're looking to streamline your personal or business life with AI, you can check them out at embersilk.com.
So back to the hardware. That fiber loop is the big sort of sci-fi angle.
Right.
But Carmack had a second proposal that's actually, it's buildable today. Using flash memory.
The stuff in a USB drive?
The very same. Now, flash is cheap, but it's got terrible latency compared to high-end RAM. It's slow to start reading.
But you're saying quantity has a quality all its own.
Oh, that's the idea.
Yeah.
You don't read from one chip. You gang together thousands of them. You wire up this massive array of cheap flash chips. You pipeline the requests, and you completely mask that initial latency.
So you trade latency for just massive parallel bandwidth. It's like opening 1,000 books at once instead of trying to read one page really, really fast.
That is a perfect analogy. And it's viable for AI inference right now. It just needs the flash vendors and the accelerator companies to agree on a high-speed interface.
And researchers are already on this.
Oh, absolutely. Concepts like flash GNN or the augmented memory grid are already being explored. We are seeing this fundamental shift from storage is static to storage is motion.
That really does feel like a different way of visualizing a computer. Not data sitting in a warehouse, but data as a constant stream flowing through the processor.
And if you zoom out, it suggests the future of computing might look less like these boxes of silicon chips and maybe a bit more like a nervous system.
A vast network of light and motion.
All synchronized perfectly.
It makes you wonder, if we can store 32 gigabytes in a beam of light today, what's next? Are we moving toward computers that look more like star charts than circuit boards? It feels like a very bright future.
I think so. The potential for efficiency is just limitless.
Well, if you enjoyed this deep dive, please subscribe to Intellectually Curious. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.